As we continue with the basics of Euclidean geometry, we want to talk about measuring lengths and angles. And so the student will be able to identify a midpoint or bisector of a line segment or angle. Okay, so the midpoint would be somewhere halfway in between, or bisector. What they're saying is that midpoint and bisector is cutting it perfectly in half. So that is what creates two congruent segments, is when you cut it in half or you bisect it or find the midpoint. Then also apply the ruler postulate and segment addition postulate to calculate the lengths of line segments, and then apply the protractor postulate and angle addition postulate to calculate angle measures. Well, segment addition, we're talking about lengths, so we use a ruler. And then for angle addition postulate, for angles, you use a protractor in order to measure angle in degrees. So that's where we come up with the protractor or angle addition postulate using that protractor. This is, again, much of the same stuff that you were probably doing in many younger grades, but we're just putting different names to it, the official names to it. And so midpoint is halfway, cutting something in half. A congruent segment means they're identical, because that's what congruent means. Distance, we're going to talk about that when we talk about segment addition, that distance is always going to be positive. So distance has an absolute value. And then to bisect, of course, means to cut something in half. Just simple words that we need to make sure that we're comfortable with as we move forward. So when I talk about measuring segments, if I have a length, if I have a length and I know that from here to here, well, if I tell you that that is 12 units, then that means if I take and I label this A and I label this C, so the segment AC should be equal to 12 units. Well, if I find out that this is point B, the segment addition postulate would tell me that if I have segment AB, this portion, plus segment BC, which is this portion, that is going to be equal to the overall length of that portion, which is going to be equal to segment AC. Welcome to the addition postulate. So it's just saying that if the entire length is equal to a certain amount, then one portion of the length plus the other portion of the length would be equal to that same amount. Let's try this algebraically. However, before I start talking about algebra, let's just go ahead and look at that distance that I created of 12. And if I look at this as a number line, we see that the length of AC actually goes from 3 all the way to 15. And using the absolute value, well, that would be the distance there is going to be the absolute value of 15 minus 3, because this is 15 is where the largest number, that's where I ended up. 3 is where I began, so I subtract that distance. So I have 15 minus 3 is going to be equal to the absolute value of 12, and the absolute value of 12 is 12. So that's how I come up with that distance, or that length is always a positive length. So let's see here, moving forward with algebra now. Okay, so if I take this and I use this as an example, and for the segment addition postulate, some of the things here that we're looking at is I have a line, I have 3 points drawn on here, but it's telling me that RT is equal to 5x minus 1, and ST is equal to 2x minus 2. And then what would I find out is, what is RS equal to? And so if I do some substitution, what I want to do is I'm going to take these values and I'm going to substitute them in for their length. So I know that, first of all, I'll start with ST is going to be 2x minus 2, and that is this distance right here. And I know that RT is going to be this distance right here, and that is going to be 5x minus 1. Now what I'm trying to find out is, what is RS? What is this segment right here? And how would you figure that one out? And take a moment, and if you need to, stop the video. But, well, I want to figure out what the heck RS is. I'm going to take the entire length. I'm going to take the entire length, and I'm going to subtract this portion of it right here. So if I set that up in an algebraic equation, I will have, I'll have RT minus ST is going to be equal to RS. So if I do that substitution, I know that RT is going to be equal to 5x minus 1 minus substitution of ST, which I said was 2x minus 2. Now I have to do simplifying. So just remember, when you're doing this, you need to distribute your negatives, so you're always adding polynomials. So negative times a positive will give me negative 2x. That negative times a negative will give me a positive. So if I rewrite this, it really is 5x minus 1 minus 2x plus 2 equals. When I go to combine like terms, I can combine my variables, and then I can combine my numerals. So in combining my variables, I have 5x minus 2x, which is going to give me 3x. I have a negative 1 and a positive 2, which is going to give me 1. And that is what equals RS. So RS is going to be equal to 3x plus 1. There you go. So that's using the addition postulate. And let's go on here and talk about the angles. Okay, so when we're measuring angles, we need to make sure that we got some terminology. We need to understand some terminology here, so that's why I put these vocabulary words in. So let me go ahead and draw a quick example here. Okay, so we will start with some stuff that you've probably already seen. So I have a showing here, if I do this, as we talked before, that means a 90-degree angle. So this should tell me that this angle right here, that angle right there, is going to be a 90-degree angle, which is also a right angle. So a right angle is exactly 90 degrees. Now if that's 90 degrees, that tells me that over here is 90 degrees. So this angle right here is going to be 90 degrees. Okay, now if this angle is 90 degrees, this angle is 90 degrees, that makes them congruent angles. Okay, congruent angles are the same angle. So a 90-degree angle is congruent to another 90-degree angle. Now, a obtuse angle would be something that is going to be greater than 90 degrees, but is going to be less than a straight angle, which is going to be 180 degrees. So a obtuse angle is going to be somewhere between 90 degrees, but less than 180 degrees, because a straight angle is going to be 180 degrees, and that would be this straight angle right there. Straight line is 180 degrees. And the only thing we didn't really cover is going to be the acute angle, and that is going to be this measurement right here. An acute angle is going to be, well, it's going to be greater than 0 degrees, but it's going to be less than 90 degrees. So we talked about that congruent, we talked about our different measurements here, and then what does adjacent angle mean? Well, adjacent means next to. So this angle right here is going to be adjacent to this angle right here because they are right next to each other, and they are two angles within the same plane that share a common side and vertex. Okay, so they both share this length right here and a vertex. So this angle is adjacent to this angle. So those are your key terms when we're talking about measurements. And let's see, what else can we do? Okay, so we do have one angle that's called a reflex angle, and that is going to be something that is going to be greater than that 180 degrees, but less than 360, and 360 being a full circle. And so looking at this ABC that angle ABC that I just put here, we would measure that. It could be measured going this way. So if I measured that, that is going to be greater than 180 degrees. So that is going to fall somewhere between 180 and 360. So just keeping that in mind, there's multiple types. And then let's see here. So using our addition postulate, let's draw a quick diagram. Okay, so looking here, given this diagram, it looks like I have an obtuse and acute adjacent angles, and it just looking at the diagram, and then it has asked me, or I'm asking you to find the measurement of angle ABD. So little m angle ABD, that stands for the measurement of angle ABD. So if looking at my diagram, of course, this is ABD right here, and so I know that the measurement of angle ABD is equal to the measurement of angle ABC plus, okay, so here is ABC, plus the measurement of angle CBD. Oops, didn't mean to use that. CBD is that angle right there. So if we do our substitution, we have the measurement of ABD is equal to the substitute here of ABC is going to be 110 degrees, plus the substitute of CBD, which is going to be 30 degrees, is going to give me 140 degrees. This is using my angle addition postulate. So the measurement of angle ABD is equal to 140 degrees. There you go. And that is my addition postulate. And again, positive. Lengths have to be positive. Angles have to be, in this case, positive. And that is what we will be working with as we continue to measure angles and lengths. If you'd like to continue with another example, you're welcome to. You're welcome to go on to your assignment here at this point in time. But if I use some algebra, and let's see if I just draw some really bad angles here. Okay, and it looks like I have 1, 2, 3 angles. So I have a B. Gotta have some segments here so we can start labeling stuff. We'll go with D, B, C, and let's see here, we can do some labels. We'll say this is going to be 3x plus 2, this angle measurement. Then here we'll go with 4x degrees, and here we can go with 2x plus 6 degrees. Okay, so here's our angle measurements for those, and then, but if I need to find out, well, what does x equal? Solve for x. I'm giving some information that, let's see here, if angle AED, I need to have enough information. So if I know what the complete angle is, right, from AED. Let's see, we'll give that a number of, how about a number of 125 degrees. Okay, so then I know that AED, so I know that the measurement of AED is going to be equal to the measurement of angle AEC plus the measurement of angle CEB plus the measurement of angle BED. Now I can do my substitution now that I've sort of written this out just by showing what it looks like. So as I substitute in my values, for AED we said is equal to 125 degrees. That is going to be equal to the measurement of AEC, which is 3x plus 2 degrees, plus the measurement of CEB, which is going to be 4x degrees, plus the measurement of BED, which we said is going to be 2x plus 6 degrees. Now we can combine like terms, and remember when we're combining like terms, we can combine our variables, and then we can turn around and combine, in this case, our numerals, because those are our like terms. So in doing so, I still have 125 degrees on this side, and then 3x plus 4x plus 2x is going to give me 9x. Plus, I have 2 and a 6, so I add those together, I get 8. And now I just continue solving my equation. So I end up with, I subtract 8 from both sides because I want to cancel that out because I'm trying to isolate my variable. So that becomes 125 minus 8, which is 117 degrees, equals 9x. I go ahead and now, in order to get my x by itself, I divide both sides by the coefficient, which is 9. And then x is going to be equal to 13 degrees, I hope. So let's go back and check that. 13 times 9 looks like it's going to be 27, carry the 1, and we're good to go. So x equals 13.